Hello, welcome to Cloud Learning channel. In this module, we will learn how to design a oil and gas tank level forecasting system in Azure Analytics platform. In our previous module, we learned how to design a real-time fraud detection system, and also we learned how to design a predictive aircraft engine monitoring system. So in this module, I will cover how to design oil and gas tank level forecasting system. And I will also talk about the list of components that we need to design this oil and gas tank level forecasting. And also I will talk about the data flow and the steps involved to design this system. And also I will talk about the potential use cases where we can use this architecture. Okay, let me start with the list of components that we use for this system. So here are the list of components that we need to design this architecture. So Azure Data Factory, Azure Event Hubs, Azure Machine Learning, Azure Stream Analytics, Azure Synapse Analytics, and Power BI. So before I move to architecture part, I will quickly discuss about this list of services and what are they for, why we use these services in Azure. Let me start with Azure Data Factory. So Azure Data Factory, it handles orchestration and scheduling of the hourly model retraining. And we can also use Azure Synapse Studio. So they both perform same activities, but it's up to you, whichever you want to use it, but both are suitable for this architecture when it comes to ELT2. And let's talk about Azure Event Hubs. Azure Event Hubs we discussed in our previous modules. So it can connect to source system, and bring the data and store it in Azure Event Hubs itself. So after that, either Stream Analytics or anything can connect to these Event Hubs and bring the data, and we can do the transformations. And in this scenario, especially the data feeds into the Azure Event Hubs and Azure Synapse Analytics service as the data points or events that will be used in this rest of the solution. And Azure Stream Analytics analyzes the data to provide near real-time analytics on the input stream from the Event Hub and directly publish to Power BI for visualization. So here in Azure Stream Analytics job, our input is Azure Event Hubs where we access the data, and our output is Power BI where we push the data to Power BI for visualization. So we can build dashboards and visualize all the data using Power BI. Azure Machine Learning. It is used to make forecasts on the tank level and particular region given in the inputs received. And Synapse Analytics, we already discussed. Synapse Analytics is used to store prediction results received from Azure Machine Learning. And these results are then consumed in the Power BI dashboard. So if you guys remember, we in the aircraft system design, we use the same method, the predictive aircraft engine monitoring architecture. So we use Synapse Analytics, access data from Azure Machine Learning and store everything in Synapse Analytics and send the data to Power BI for visualization. So finally, final service is Power BI. So we know why we use Power BI. It's a BI tool where we can visualize data, we can build dashboards, and we can do we can modify, we can add the filters, and we can make the dashboards according to our requirements. So Power BI is used for results visualization so that we can monitor the tank level from a facility in real time and use the forecast level to prevent spillage. Yeah, let me move to architecture. So here in the architecture, you can see that our source systems, we have two sources, data in motion and data at rest. So if you see data at rest, it's just a one-time ingestion of historical data. So let's talk about data in motion, the near real time. So how we access the data in motion. So we use Azure Event Hubs to connect to this data in motion that's a near real time and bring the data and store in the Event Hubs. So once we have data in Event Hubs, and what is the next step? Then we use this Azure Stream Analytics, and Stream Analytics analyze the data to provide near real-time analytics on the input stream and directly publish to Power BI dashboard. And if you see that, right, so let's say our step one is bring the data and store it in Azure Event Hubs from the source. And the second step, create a job in Azure Stream Analytics and bring the data from Azure Event Hubs. Our input is Event Hubs in Azure Stream Analytics job, and do all the transformations, and we can apply the SQL, and we can do the customized SQL. And once we have that final data, and we can directly publish to Power BI. So before we move to Power BI part, so let's talk about Azure Synapse Analytics here and machine learning and data factory. So the Azure machine learning is used to make forecast on the tank level of particular region given the inputs received. So here, once we have data available in a Synapse Analytics, and we store the prediction result received from the machine learning, and these results can consume directly in the Power BI dashboard. So in the Power BI dashboard, we have a connector available. So you can connect to this Azure Synapse and collect all the data. And here, if you see that I mentioned either Synapse Studio or Data Factory. So you can use any of these ETL tools. You can use either Synapse Studio or Data Factory, and you can do everything. If you want to use Azure Synapse Analytics, it would be nice if you can keep everything within Synapse Analytics using Synapse Studio. And if you go to integration part where you can build a pipeline, and you can handle the orchestration and scheduling of the hourly model retraining. And also, if you look at the batch data, where we can directly send the data to Azure Synapse Analytics, one-time historical data, and from using Power BI, we can connect to Synapse Analytics. So, and we can monitor the tank level from a facility in a real time and use the forecast level to prevent spillage. But historical load is not like a real time, but if you see data in motion, that's our near real time where we use Event Hub and then Stream Analytics and send the data to Power BI. So machine learning can connect to Synapse and access data, and it is used to make forecast on the tank level of particular region given in the inputs received, and then send the data back to Synapse, where Synapse we can store the data, because Azure Synapse Analytics is designed to hold the massive data. That is our data warehouse in Azure. So where we can use DW usage, like we can if we want a good performance in Synapse, so the minimum starts from 100 DW, but we can scale up to 30,000 DW. It depends on our data volume. If you have 100 to 100 GB, I think 500 to 1000 DW usage is fine, and where you can design tables and use the right distribution. But if you have more than 1 TB, so you can keep scale up the DW usage. So we discussed all the steps, how to design this oil and gas tank level forecasting. So before I move to the potential use cases, I will quickly go through the steps again. And here the first step, the data feeds into the Azure Event Hubs and Azure Synapse Analytics. Because if you see the data in motion, that's Azure Event Hubs. And if you see the blue one, data address, that is Azure Synapse Analytics. So the data feeds into these two services as data points or events that will be used in the rest of the solution. And the second step, if you see the Azure Stream Analytics, it analyzes the data to provide near real-time analytics on the input stream from the event hubs and directly publish to Power BI for visualization. And the third step is Azure Machine Learning, and machine learning is used to make forecasts on the tank level of particular region given the inputs received. And the step 4 is Azure Synapse Analytics is used to store the prediction results received from Azure Machine Learning. And these results are then consumed in the Power BI dashboard. And the fifth step, where we see a couple of ELT tools, one is Synapse Studio or Data Factory, but the both handles the orchestration and scheduling of the hourly model retraining. And the step 6 is Power BI. So Power BI is used for results visualization so that we can monitor the tank level from a facility in real time and use the forecast level to prevent spillage. Let me move to the potential use cases. So before I move to potential use cases, let me talk about the scenario details. The tank level forecasting process starts at the well input. So oil is measured as it comes into the facility via meters and is sent to tanks. So the levels are monitored and recorded in tanks during the refining process. So oil, gas, and water output are recorded via sensors, meters, and records. So let me talk about these potential use cases. So these forecasts are created by harnessing the power of real-time and historical data readily available from sensors, meters, and records. So which help in these scenarios. Um, it can prevent tank spillage and emergency shutdowns, and we can discover hardware malfunction or failure. We can also schedule maintenance, shutdowns, and logistics, and optimize operations and facility efficiency. And we can detect the pipeline leaks and slugging. And also, and the last one, we reduce cost, fines, and downtime. And if you have any questions, like, how to deploy the services in Azure, and we used in the previous architecture, right? So if you want to know how to deploy and how we can configure in Azure, if you have questions about event hubs or stream analytics, Synapse Analytics, or machine learning, Data Factory, Synapse Studio, and please go through my channel, and in the search, you can just type these services and you get plenty of videos where you can explore, and you can find out how these tools works, how to deploy, and how to, configure and how to maintain. And if you have questions how to scale up and scale down, that I discussed about DW usage in Synapse, so you can also find out in my channel. Go to Synapse analytics architecture videos. And if you want to build a pipeline, example, if you are getting data from on-prem, and suppose you want to process batch data using one of the ELT tool, either Synapse Studio or Data Factory, you can also find that in my channel. If you have any questions about this oil and gas tank level forecasting, and please post all your questions in the comment section. Not only this oil and gas tank level forecasting system design, but if you have any question on any other use case, or if you have any question on any service, please do not hesitate. Please feel free to post every question in the comments, and I will try to reply as soon as possible. If you like this video, please subscribe and share the channel. Thank you.